Is it visible? Share screen.
Yes, sir. Visible, sir.
Visible. Okay.
Yes, sir.
Okay, let us start. Hope the other students will join. Okay. So today we'll discuss about the atmospheric pressure. So where there is a variation like a diurnal variation, seasonal variation, then pressure systems of the world, and also what are the causes for variation, what is the low depression effect, cyclone, anticyclone, tornado, hurricane, storms, so many things we are using. So many a time we are using low pressure area. So recently, so 5-6 days back, we are experiencing the low depression, low pressure area or depression effect from the Bay of Bengal, where the most part of the state got the rainfall due to the depression effect. Okay, so that we are experiencing. So when we are experiencing, we can know the effects, how it is. So continuously there is a soaking rains, drizzling. Okay, the temperature coming down, so chilling. So all that you are experiencing. Of course, the cyclonic effect are especially in the coastal belt and in the island regions. Tornado and all in some of the countries we are seeing that hurricane, and it is being called by different names by different parts. Okay, coming to the atmospheric pressure. So most of you are also heard the name. What is pressure? So what is atmospheric pressure? So we say atmospheric pressure is the weight of air. It is the atmospheric pressure is the weight of the air which lies vertically above a unit area centered at a point, indicating that it is the weight of air in the atmosphere. Okay. So the weight of the air passes down the earth with a pressure of 1.034 gram per square centimeter, and also it is expressed in millibars, which is equal to 1000 dynes per square centimeter. So this pressure is due to the unequal heating of the earth. Equal heat of the earth and its atmosphere by the sun and rotation of the earth bring about the differences in atmospheric pressure. So that pressure is due to differential heating of the earth. Okay. So when the earth heated up, so it also absorb the radiation, then radiates. Where near the earth, the air gets expands and it is moving of the air which is vertically above the unit area centered at a point. Okay, so the pressure will be around 1.034 gram per square centimeter, and it is also expressed in millibar equal to 100 dynes per square centimeter. So then, so I think you might have seen the isobar lines in the book. So where these are the imaginary lines. These are the pressure of similar pressure lines are given, which are imaginary lines we call. So the isobars are nothing but the distribution of pressure is represented on maps by isobars. So these are imaginary lines drawn on a map to join places having the same atmospheric pressure or places having similar atmospheric pressure. Similarly, you might have also see the ISO heights, ISO bars like that in the map, Indian map or Karnataka map or in the world map. So these are the imaginary lines are drawn to make you to understand or to make us to understand. So where similar pressure lines exist. Okay. So ISOs are those. So it is imaginary lines drawn on a map to join places having the same atmospheric pressure. So we have the variation in the pressure. So there is a variation in the pressure. It may be a daily variation or it may be a seasonal variation. So as you are experiencing, so there is a variation in the pressure, daily variation, which you call it as the diurnal pressure variation, and the seasonal pressure variation also we are seeing. So if you take the diurnal pressure variation, so there is a definite rhythm in the rise and fall of the pressure in a day-to-day activity. So it will varies. Okay, there will be rise and there will be fall in the pressure. So this is due to radiational heating. So when there is a heating of the earth where the air expands, and when the radiation cooling, it contrasts. Okay, air will contrast. So these are the reason why there is a variation in the daytime. Pressure variation is due to the differential heating and cooling of the earth. Okay, by the radiation. It is radiational heating. Okay, where air expands, and radiational cooling means air contrasts. So these are the reasons where there is a diurnal variation in the air pressure. So this is more prominent near the equator because of heating is more near the equator where there is a air expansion takes place, then movement also takes place compared to other latitudes. So the areas closer to sea level record relatively larger amount of variation than the land surface because so the water heats slowly. Okay, but once heated up means so there is a variation, and also cooling is also slow in case of the water bodies. Whereas in land masses, so heating is also fast, and also cooling is also fast. So the equatorial regions absorbs more heat than it loses, while the polar regions. So these are the things you can able to study when the notes is sent. Okay. So the diurnal variation is due to differential heating of the Earth surface and also the environment due to the radiational heating. That is where the pressure difference takes place. So seasonal variation, if you take, so due to the effect of it is due to the effect caused by annual variation in the amount of insolation. So it is a cumulative variation in the amount of insolation. So distinct seasonal pressure variation occurs. Okay, so much variation in the insolation. So is due to the reason so that there is a variation in the pressure. So these variations are in a larger in tropical region where the temperature is also more or heating is also more, radiation is more than the mid latitude or polar regions. So the variations of pressure in tropical regions is more, as we know that more heating of the earth. So usually the high pressure are recorded over the continents during the cold seasons and over the oceans during the warm season. Those things you can go through that. Then coming to the pressure systems of the world. So different pressure systems of the world have been classified. So the shape of, we know that the shape of the earth is not uniform because it is subjected to uneven distribution of solar radiation. So when the earth is rotating, so it is there is a different heating in the equatorial region than in the polar region. So as you're already aware of that. So the shape of the earth is not uniform and subjected to uneven distribution of solar radiation. So when it revolves around the sun, that you are knowing. So this uneven distribution of solar radiation over different regions of the globe leads to the contrast in surface air temperature. Definitely there is a variation in the surface air temperature due to the insolation effect, incoming solar radiation. It varies from place to place and region to region because of the differential so heating. Okay. So this results in variation in surface atmospheric pressure also. So this also results in variation in the surface atmospheric pressures, which are known as standard atmospheric pressure systems. They are called as the standard atmospheric pressure systems or belts. Standard atmospheric belts. So there are altogether seven alternating low and high pressure belts. There are altogether about seven alternating low and high pressure belts on the Earth surface, and they are: number one is equatorial trough of low pressure. Equatorial trough of low pressure between 5° north and 5° south latitude. So this you can see in the this graph. You can see in the later stage. Okay, so equatorial trough of low pressure between 5° north and 5° south. The second one is subtropical high pressure belt. Subtropical high pressure belt in the north hemisphere, which is lies between 25 and 35° north latitude. The north subtropical high pressure belt in the north. So here subtropical high pressure belt in the north between 25 to 35° north. So similarly, the subtropical high pressure belt in the southern hemisphere between again 25 and 35° south. Subtropical high pressure in the southern region between 25 to 35°. So then, so subpolar low pressure belt of the north, subpolar low pressure belt of northern hemisphere between 60 and 70° north. Between 60 and 70°, subpolar low pressure, subpressure, so low pressure. So then similarly, so then subpolar low pressure belt in the southern sphere. So the this is the southern sphere, subpolar low pressure, and of course polar high in the north hemisphere and the polar high in the southern. So this is the polar high of the northern hemisphere and also the polar high of the southern hemisphere. So these are the seven pressure belts in the world. So the equatorial region receives more solar radiation, as we are knowing, because Earth is nearer to the sun comparatively. So and thus the surface air temperature is high. The surface air temperature is high, which creates lighter air near the ground. So when the air heated up, the pressure will comes down. It started moving upwards. Okay, so when it heated up, it creates a lighter air near the ground compared to higher latitudes. So the above conditions lead to low atmospheric pressure over the equatorial region, while subtropical and high pressure belts develop in both the hemispheres between 25 and 35° latitudes due to relatively low surface air temperature. So it is due to low solar radiation received due to inclined sun's rays over the subtropical region when compared to the equatorial belt. So likewise, alternate low and high pressure belt systems are developed across the globe from the equator to poles. So if you see the from equator to the poles either towards the north or south, so there is a temperature variation. Higher temperature will be there in the equatorial. As a result, the air near the equatorial, it becomes light and pressure will be so variation. So accordingly, the movement of the air will also takes place. Accordingly, the low pressure and high pressure belts will be forming. Okay. Then causes of variation. What are the causes of variation? So the atmospheric pressure changes continuously due to several factors. See, the pressure changes continuously because of differential heating. Okay, the atmospheric pressure changes continuously due to several factors. The most important factors are change with temperature. So main is the most important factor is change in temperature, altitude or height, water vapor content, and rotation of Earth. So these are the major factors where causes in the variation of atmospheric pressure, mainly with the temperature, then the altitude, then the presence of water vapor, and also the rotation of the Earth. So if you take one by one, so what is the effect of this temperature? So we know that hot air expands and exerts low pressure. So when When the hot air, when the temperature is more, the air expands and exerts a low pressure. So whereas cold air contracts and exerts high pressure. So the equator has low pressure due to prevalence of high temperature, but poles have the high pressure, which this is the phenomena, a phenomena, okay, where we studied in the physics and other courses. So then altitude, height. Okay, so at sea level, the air column exerts its full pressure, but when we stand on a hill or when we go to upper layers of atmosphere, we leave a portion of air which cannot exert its full pressure. At sea level, a coastal town enjoys high pressure, but on high altitudes, one will register a low pressure. For every 10 meter of ascending order of height, the pressure get reduced by 1 horse Pascal. So get reduced by 1 horse Pascal. So these are the phenomena we studied in physics. Similarly, water vapor. So the water vapor contains lighter in cold area than air which is dry to the result that moist air of high temperature exerts a less pressure compared to the cold air. So these are the phenomena which are taking place in the atmosphere. So these are the physical effect. Okay, so we study in physics and other courses. Of course, meteorology is so usually we studied in the physics only. So when we were students where the physics courses where these are the processes related to physics. So then coming to the water vapor, the water vapor content is lighter in cold area than air in hot area. So when we are standing on a hill or when we go to upper layers of atmosphere, so makes the air to escape from these belts, which move towards the horse latitude, either so in the northern hemisphere or in the southern hemisphere. So this would absorb the air from subpolar belts, making the pressure high. So a scientist by G.D. Coriolis, as early as 1844, a French mathematician, indicated that air is deflected towards right in the northern hemisphere and left in the southern hemisphere due to rotation of Earth. And this was also termed after him as Coriolis force. It is also termed as Coriolis force, which is nothing but so this is not actually force, but it is the effect created by rotation of the Earth. So it is an effect created by the rotation of the Earth. So these are the things which are available in the literature of this phenomena. Then the low area or depression, low pressure or depression effect. When the isobars are circular elliptical in shape, when the isobars are circular or elliptical in shape, and the pressure is lowest at the center. So when the isobars are circular or elliptical in shape, the pressure is lowest at the center is called low. Such a pressure is called low or depression effect or cyclonic effect. The movement will be anti-clockwise in the northern hemisphere while it is clockwise in the southern hemisphere. So as it is given by the scientist. So this horse exceeds 40 kilometer per hour, and it may pick up and it may changes also depending upon the height and speed. Indicating that the low pressure area, high pressure area, you can able to study for more. Then anticyclones. So when isobars are circular, elliptical in shape, and the pressure is highest at the center, such a pressure system is called high. When the isobars are circular, elliptical in shape, and the pressure is highest at the center. Pressure is highest at the center. Such a pressure system is called high pressure. or anticyclone. Whereas when the isobars are elliptical rather than circular, the system is called as ridge or wedge, and the movement will be clockwise in the northern hemisphere, while it is anti-clockwise in the southern hemisphere. Southern hemisphere. The depressions and anticyclones. Depression pressures, okay, below 1000 millibars. Depressions are nothing but low pressure area created below 1000 millibars, whereas anticyclones are high pressure systems above 1000 millibars. So, where in depressions, higher wind speeds shown by closer together isomers, it is closer. C is missing here. Higher wind speeds shown by closer, higher wind speeds shown by farther away isobars. Farther away isobars. So anti-clockwise winds moving inwards, whereas clockwise winds moving outwards here. So air is rising and creating low pressure due to less pushing down, whereas here air is subsiding and creating pressure due to the pushing down. Sometime differences of these things may be asked. We have to go through the notes again today. Then other terminologies like a storm, hurricane, thunderstorm, so many the terminologies we use. So what is storm? So storm is a low pressure center surrounded by winds having their velocities in the range of 40 to 120 kilometer per hour. Storms. I think you might have seen in the Discovery Channel or in the news channels. So how the storms are formed and how the damage is being made, where the trees may be sometime bending towards the ground or sometime uprooted, especially the palms and other trees are bending and breaking, and so many the terrace sheets and other things will be taken away by the wind. Electrical poles may be so coming down. So many things are happening. If it is a storm which is about more than 100 kilometer per hour, means nobody can able to control. Even the dust and everything will be moving in a faster rate. Sometimes even vehicle movement maybe so due to higher velocity of wind tilting. So many things happening, and the animals and the man will be at risk. So a more favorable atmosphere condition for their occurrence exists during the summer season. So especially when the earth heated up, so what happens? The air near the earth will get heated up, it expands and start moving upwards, and upper air moving downwards, so that air circulation starts. So differential heating starts air circulation. That is how the wind movement starts, and also the cloud movement. So this is the reason where storms forms. So the Bay of Bengal and Arabian Sea offer ideal condition for origin and growth of the storms. So these storms produce heavy precipitation or rainfall and bring about a change in the existing weather. So it occurs very rarely. So differential movement of air from the land mass to earth and earth to land mass to ocean and ocean to earth, which creates a storm. Okay, the when the air movement starts from the earth to sea and also sea to earth, so it starts creating these things. Then the hurricane. So hurricane, a severe tropical cyclone with the wind speed exceeding 120 kilometer. I think somebody has to mute. Unmuted your audio. Kindly mute our audio. Cyclone wind speed exceeding 120 kilometer. It is up to 120 kilometer per hour. Hurricane wind speed is exceeding 1 kilometer per hour. You can imagine the damage created by the hurricane. So what is the damage you can? So the name hurricane given to the tropical cyclone in the North Atlantic and the Eastern Pacific Ocean. Given to name hurricane is the tropical cyclones in the North Atlantic and the Eastern Pacific Ocean. So the tropical cyclones of hurricane, it is called by different places in a different manner. In Australia, this type of storm is given the name Willy. Okay, whereas in the Indian Ocean they are called as cyclones. Hurricanes are fueled by water vapor that is pushed up from the warm ocean surface, so they can last longer and sometimes move much further over the water than over land. So a combination of heat and moisture along with the right wind conditions can create a new hurricane. So this the hurricane is so in a simpler manner if I put it, so it is a wind which is moving with more than 120 kilometer per hour with so much the water vapor in it and creating so much havoc when it is formed. Okay. So then thunderstorms, along with the storms, thunder will be there. Storms produced by cumulonimbus clouds. I think you might have seen the cumulonimbus clouds, a dark colored clouds. Storms produce cumulonimbus clouds and always accompanied by lightning and thunder. I think in the rainy season you might have seen how the thundering and lightning is happening. First we see the light, then we hear the noise or the voice. Okay, because of the speed of light and the sound, as you already know. So when the clouds are dashing or hitting or colliding, so much the heat electricity is being produced that using in the form of light and also the sound later. So thunderstorms produced by cumulonimbus clouds. The clouds will be very big, like one villages are collide. Okay, in the atmosphere, where so much tons of thousands of tons of the ice is going to hit the other the cloud. As a result, there is electricity is being produced that is the lightning. Okay, sometime when the lightning hit the trees or the houses, immediately it will start burning. Okay, so those things you are seeing. As a result, in the high story buildings, they also putting the lightning conductors. Okay, so earthing will be done like that. Okay, even in the when we connect electricity, we are doing earthing so that it has to leave to earth like that. Storms produced by cumulonimbus clouds and always accompanied by lightning and thunder. So they are usually of short duration, seldom over 2 hours. They are also accompanied by strong wind gusts, heavy rain, and sometimes hailstones. So this thunderstorm will not long for more than more than 1 or 2 hours, because so when high thunderstorms means so all the clouds are hitting. So after some time the rain may stop. Okay, so they are colliding each other. So it will not for a long time. Then comes tornadoes. Tornadoes, so defined as violently rotating column of air. Tornadoes defined as a violently rotating column of air attended by a funnel shaped, shaped or tubular cloud extending downward from the base of cumulonimbus cloud. Tornadoes are defined as violently rotating column of air attended by a funnel shaped or tubular cloud extending downward from the base of cumulonimbus cloud. So these tornadoes are the most violent storms of the lower troposphere. Tornadoes are the most violent and dangerous storms of the lower troposphere. They are very small in size and of short duration. So they are mostly occur during spring and early summer seasons, and they have been reported at widely scattered location in the mid latitudes and tropical regions. So here the crop losses are very heavy or high due to this event, and unknown in other parts of the world, indicating that the crop losses are heavy. If it is in the forest area and other things, so no problem. But we do not know. In the cropped area means everything will be uprooted, so much damage you can see. But only these things are not more common. So these are the extreme conditions of the phenomena. So sometime it will happens due to the weather differences occurring in the atmosphere and on the earth. Then the water sprouts. So the water sprouts is a column of violently rotating air over water having a similarity to a dust devil of tornado. Water sprouts is a column of violently rotating air over water having a similarity to a dust devil of tornado. In other words, tornadoes are weak, visible vortices occurring over water are called water sprouts. They are formed over tropical and subtropical oceans. So, in some of the oceans, these things are created. Many a time we may not experiencing, but the predictions are given through the satellite and other things. So then, why cyclone is more common in Bay of Bengal or Arabian Sea? So the Bay of Bengal is warmer than the Arabian Sea and thus more conducive to cyclone development. And cyclones that move from the Bay of Bengal towards the Arabian Sea loses much of their potency while traveling over the Indian Peninsula. While traveling to the Indian Peninsula. So these are the things where I wanted to discuss with you people. So if it is offline means you would have thoroughly explained by using a blackboard and this one. But in the online means literally we are going fast. There is no, don't worry about that. So the notes will be sent today. So the CR should give the mail ID. Okay, afterwards you can go Siddhesh. So you send your mail ID to my WhatsApp number so that I can send the notes of these four chapters. Okay. So here we go through the
Okay,
notes.
sir. Okay, sir.
You understand the concept, and also I think you are aware the when you come back. Kindly take a good number of agrometeorology books are there by Vasne and other. This one I will give the good references where you can understand the still better way also. Apart from the notes, if you go through the book also, so there is a better understanding also. And even of course, some of the concept you can understand. Now in the Google also, if you put meanings, everything is available. And so many now it is the information world. You need not worry much about the things as we were in earlier days. It was very difficult to collect information. Nowadays it is easy to get the information. Of course, this soft copy I will share today, so you can see. I go through the all the four chapters. You can read twice or thrice so that you can understand. So wherever you are not understood this one, you can make a questions. Okay, on side you can write down what the concept if you are not understood. But if you go through this, you can definitely understand the concepts. So so this is the today's class, but each and everything you have to read carefully. So when you read twice or thrice, first you will understand the concept. When you read once, so you may understand 50 to 60%. So when you read twice or thrice, you can understand it to the maximum extent. And if some of the things, if it is not so clear, we can write one side which is not clear. So accordingly, that can be explained later, or we can also go through the the books and also collect from the Google also. Okay, so like that we can make the concept understandable. So if you take the Indian Meteorological Department, IMD, there is a separate department called where they are monitoring about these processes. So in from the central government, now it is comes under the Earth Science, comes under the Ministry of Earth Sciences. So everywhere there is a agrometeorology unit should be there. Pool is being made at the Mobile level, Taluka level. So like that it is spread over. So Indian Meteorological Department is monitoring all these things. So where usually the physics background and science background people are recruited there. So and accordingly they are monitoring. So even in the seashores, ports, and also whereas in the uh, airports and all, their role is much more. So as I already told, there is a separate agrometeorology department is coming, and from next year in our university also, separate agrometeorology department is coming headed by the and separate MSc program is also coming in the agrometeorology the unit. So indicating that so we concentrate on reading of these things. So again there is a so one the MSc advisory committee meeting is there. I have to attend because of the low staff position. We have to engage more work. So this program is going on. So I have to attend one the advisory of MSc student and also one colloquium of MSc student. So I will stop here. Okay, I stop here and that work. So
Okay, sir.
Gavisiddhesh, you send your mail ID. So I share this folders upload to the other students. Okay. So
Okay.
now I will stop here. So thank you.
Thank you,
Okay.
sir. Thank you, sir.
Okay. Bye bye. Thank you. Bye.